Hey, what's up, dudes and dudettes? Brad the Gheytards here. I'm unboxing this so we can get to work on it. It was sent to me by someone, and I just wanted to document the opening of the box because I heard something kind of rattling around when I picked it up, and I want to see what that was. This is some kind of head. There's some very minimal padding on this front face right here, so I don't know what might be going on here, so I just want to document taking this thing out. This might be easier said than done, getting this thing out of this box. There's no space between the cardboard box and the actual amplifier. It's just cardboard straight on the top of the amplifier cabinet. So, you know, it would not surprise me if we see some issues. Okay, so this is a twin reverb in a special cabinet. From what I can see, it has come out pretty well unscathed. I like the purple. That's kind of cool, right? Okay, so that must have been what was rattling right there. That was on that, and I guess there wasn't a screw in it. Let's go ahead and we'll read the note. Okay, it says the tone caps and the power caps are new. The tubes are new. The vibrato needs fixing. It never worked. Fuse is popped. Uh-oh. When the fuse went, there was a lot of heat coming off the tube area and a stink. The tubes look like they have been too hot. You know, immediately I go to possible issue with the bias circuit. Maybe somebody who biased it before he got it, biased it too hot. That's a possibility. So we'll look into that. Also could be something shorted on the power supply. It also could be just a bad output tube. Even though the tubes were new, that doesn't necessarily mean that they're good. Especially nowadays, it seems like more and more new tubes are just simply not good, even from the factory. So, but we'll check all that out. Let's get it up on the bench and we'll give her a closer look. Here we are with this Fender up on the bench, and yeah, I can see this thing's got the usual tilt to the transformers, as if, you know, it's been dropped and the transformers have, you know, bent the chassis this way, kind of thing. That always happens. Ends up always happening. But this has it looks like a quad of electro-harmonic 6v6s. So I'll be looking for, hopefully, this thing to have been properly biased. This one looks like it's been hot. It's kind of hard to see, but it's just real brown up in here. Yeah, that one same way. The logo just looks really brown. Okay, see what I mean right here? The two tubes on the right, you see how the logo has a lot of color in it. It's like a lot of purple, you know, blue, purple kind of color in this, and these over here are more black or brown. Like, these have gotten hot. Okay, here we are with this thing out on the bench, and we can see not a whole lot has been changed in this. In fact, it looks like the entire bias circuit is original. There's a green line over here, is obviously, you know, some old bias for old tubes maybe. Maybe that was what the L6s were supposed to be at, with that little green line. But as you can see, it's been turned to a different location, which looks like it's about right in the middle. So I don't know, man. I wouldn't expect 6v6s to be in the middle of that wiper like that. So I don't know if this thing has been properly biased. We'll have to check that for sure. I do probably want to go ahead and change this cap, and we may do some modifications in the bias where necessary. Yeah, you know, I may also come in here and change these resistors to some metal resistors. Also, we've got the original screen resistors on the output. You can see those. There's the original screen resistor. There's one of them. There's another one. So we're going to change, we'll change those to metal types as well. That's just the stuff I can see right off the bat. The fuse has been blown. It is a proper 3 amp fuse. I don't know if you're going to be able to see it or not, but it's definitely blown. You can see the little bubbles that have happened inside of there. It doesn't look blown apart, but I think that's probably an open fuse. Okay, so the first thing I want to do is I want to, well, I'm gonna have to pop a new fuse in it. So actually, I don't know why I did that. We're gonna dial it up on the Variac. I'm gonna put the old tubes in it. I'll put a bias probe on on each pair of the output tubes, and we'll see what's going on with this thing. So I'll put one on one half and one on the other two. You know, we'll do some cleaning. He did say that there's a problem with the tremolo, so a lot of times these resistors will go out or the lights will go out. We'll have to see if the light dependent resistors is still good, as well as the light itself. We may have to make another roach for this. I've had to do that many times in the past. But yeah, all the usual things that we do on one of these, we will do. Let's just go ahead and get the tubes in it. Hook a load up to it. This also requires a 4 ohm load total. I don't know if he knew that or if he had a different load on it. But sometimes, you know, if you don't put the correct load on one of these, you can do some serious damage. Like for instance, if you plug this thing into like a 16 ohm Marshall cabinet or something, and the fact that this is a head tells me that he probably was using a cabinet. He may have been using an 8 ohm cabinet. So if the bias was adjusted at 4 ohms, that's going to change if you put it into an 8 ohm load. So you got to be mindful of that kind of stuff. This, you're not going to be able to tell it, I don't think, very easily, but this transformer, the whole thing, this whole area where this transformer is in this chassis has been bulged inward. And actually the transformer, I mean, this has all been smashed up against the top of the cabinet. I don't know if you're gonna be able to really tell it, but like the level of this, if I put my hand straight across here, there's a level, you know, none of these components can be poking up above this level, but this transformer right here has been shoved upward, and this whole area of the chassis has been bulged upward as if it's been smacked downward. That could be a problem. It might not be a problem, but the thing that's going on right now is the tubes, because this transformer is pushed up like that, the tubes are actually leaning. When you put them in the sockets, they're going straight into the sockets, but they're leaning backwards. Look at this. You see that? That tube is straight into the socket, but it is right up against the transformer. That's pretty messed up. I've never seen that before. I've seen chassis that were misshapen because they had been bashed, but you can see this transformer leaning also. It should be perpendicular like this, or you know, 90 degrees, but it's not. It's at a tilt. And this one over here, like I said, it's smashed straight up, and you can really see the bulge. I might actually have to unbolt the transformer and drop it down. I want to see what I can do with it. I might have to put it in a vise and then put something in there to push this chassis back down. Yeah, it can't stay like that. That's because the tube won't even fit in the socket without it butting up against the transformer. I don't know if that happened in transit or what, but it's definitely a problem that needs to be addressed. All right, I think what I'm going to do first, I'm going to take all of the preamp tubes out of the amp, because I'm going to probably end up having to smack on that just a little bit, and I don't want to make all these preamp tubes microphonic in the process. All these preamp tubes have been changed to Sovtex. I'm going to really have to make sure that I get this back on there tightly, because it's got the ground and everything on it. And this one has the virtual center tap on it. Okay, I'm going to take that nut off and get this out of the way. Well, I can already tell it's much better than it was, but it's I still got to get it right. I might even have to take this. Might have to take the power. Well, no, maybe not. I was going to say I might have to take the power cord out of here to get to this corner, but I'm just going to move this power cord. There's still a big bulge over here, so let's see if we can get to that. It's definitely better than it was. I'm going to drop the whole transformer out of it. That's definitely way better than it was, because the tubes are not going to lean right up next to the power transformer at the very least. So that's lowered that down quite considerably also. Hopefully on the way back it doesn't get whacked again, you know. I mean, that happens in shipping, man. You drop something and the transformers, which is a lot of mass, it wants to continue to go. Object in motion tends to stay in motion, so that's why the chassis gets bent. Okay, so that's way better than it was. It's still not perfect. It's got, you know, some bend and stuff over here, but you know, that's as far as I'm gonna go with it. The transformer would have to come out to get all the bends out, but it's pretty good like it sits now. That's way, way better than it was. And when you put a tube in it, at least now, it's not going to have that same issue where the tube is cocked back. So at least that's, you know, there's some space back here. It's not right up on the transformer. Okay, so I'll replace this fuse now, and we will dial this thing up very, very slowly on the Variac. I really want to see what kind of voltages we've got going on and what kind of plate current. Okay, so here we go. Hopefully you can see everything. We're going to dial this up on the Variac. We'll start out at 0. We'll just dial it up very, very slowly here. I'm going to put 14 volts on it. You can see there's 57 volts now at the plate. I'm measuring the plate on one side here. We're not drawing any current yet. There's not enough voltage there to fire the tubes, so they're not conducting at all. So we'll dial it up just a little bit more. Okay, we got 100 volts on the plate, 26 volts on the input, 2.3 watts overall. That's really nothing. Let's dial it up until we start drawing some current here. There, now we got a little bit of a blip. It's acting like it's wanting to take off. We've got 213 volts. That will start drawing down as we start passing some current, which we're doing. The wattage on the input is going up. We're at 13 watts now. 14, 15. So that is going up. More current over here than there is over there. And it's actually significant. There's significantly more current on this side. And this is the side with the tubes that I believe to be possibly faulty. 55 volts on the input. We're drawing less than a half an amp. Okay, I'm at 65 volts on the input. And my draw, look, I mean, you can see what's going on here. That's a lot of current, man. We're gonna dial that way down. We'll dial that down as low as it will possibly go. They are starting to even out at least. Okay, so that's as low as the adjustment will go. Yeah, I'm gonna do a quick calculation where it sits right now. We're only at 66 volts on the input, 041 on this side, multiplied by 230 volts, and that's going to be 9.5 watts of plate dissipation. The maximum on a 6v6 is 14 watts, and 70% of that is about 9.8. So we're already beyond where we need to be. So yeah, whoever did this didn't set this up for 6v6s. There's a quad of 6v6s in it, and nobody ever adjusted the bias for 6v6s. They just stuck 6v6s in and rolled with it. This side's drawing far less current now than the other side, so I don't know what's up with that either. So obviously we know that this is not correct. We're gonna have to adjust the bias control on this. We might wanna go and get a whole new match set of twos, because two of these at least, I think, have been burned, or they've been severely stressed. I would say they were probably red plating, and I want to probably contact the owner of this, see what he wants to do, let him know what's going on with it, and just kind of go from there. We know we're going to have to rebuild the bias, get that in line with 6V6. If he even wants 6V6s. Now, this might have been a mistake. Somebody might have accidentally put the 6V6s in here. Okay, we got a new match set of tubes we're going to install in this amp and see what the bias looks like. But before we check the bias on the new tubes we installed, we have to install a new set of power capacitors. Okay, so the other day I noticed a comment on one of my older videos, and the guy was like, why did you do this to this old amp? Why did you change anything? You should have left it alone. You ruined it, blah, 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 blah. When I first started doing this, I would get that all the time. It's like, why are you doing this? Why would you mess with something vintage? You're devaluing it, you know, by changing electrolytic capacitors. So what I thought I would do here, we'll test the old electrolytic capacitors and just see how bad they are on this leakage tester. Maybe they're bad, maybe they're not, but the point is, I mean, one of them at least I can see is bad just by looking at the thing. I mean, look at this. You see that right there? That's no good. It's bulged. You see how it's bulged out and it's leaking physically, but we're gonna check it for actual leakage of voltage. This is one of the ones that's not bulged. Let's check it out. Okay, this one's pretty decent. It's rated at 500 volts, and this one actually is not too bad. Surprisingly, this one would probably still be technically a working capacitor. So there's that one. That one would have been probably about okay. So let's check this one that's not bulged out and cracked. I'm up to 100 volts. And it's already not opening. The eye is not opening at all. So when the eye opens out, that's telling you that the capacitor is good and that's recovering like it's supposed to. This one's not opening at all. At all. That's a totally bad capacitor. It's fully leaky. Even down to, it's opening when you get down to less than 10 volts. But anything past that, and it's fully leaky. This capacitor is dead. Dead as a doornail. It does not like that at all. I put 500 volts. It doesn't like it. There, now it's actually finally charged up. So there it goes. It's actually charged up and it's opening. So I take that back. This one's actually doing okay. It's not opening that wide once you get up to higher voltages, but this probably would be a working capacitor too. This is the obviously bulged one. This one is physically, I don't care how this one tests, it's physically a bad capacitor. It's leaking electrolyte. I don't know how valid this test is. I think this is open. I don't think this thing is a capacitor at all, because look, it's doing the same thing whether I have the lead on there or not. So this isn't even a capacitor anymore. Yeah, 11 nanofarad is not correct. That's a bad capacitor. Let's see what this one measures at. It's supposed to be 100 microfarad. 129 microfarad. This other one's probably going to be similarly high. So it's drifted high. Yep, similarly high, 123 microfarad. Let's put it on this tester and see what we get. Again, we're looking at this right here, this opening. You see it's opening kind of slowly, which you sort of expect with a larger capacitor. It's 100 microfarad. But already it's not recovering it fully at 150 volts. And this thing's rated for 350 volts. And we have almost complete closure of the eye at 200 volts. And we do exceed complete closure of the eye at 250 volts. So this, anything above 250 volts on this capacitor, it would have been a bad capacitor. It's not, even below that, it's not a very good capacitor. So it extremely questionable, borderline bad. This one might be better than the last one. That's 100 volts. That's 150 volts, 200 volts, and it's almost completely closed. There's 250 volts, and there's just a tiny sliver of opening there. Anything above that, it's leaky. There's 350 volts, which is its working voltage, and it's completely leaky. So yeah, this is not a good capacitor either. This really goes without saying for the most part these days, but you know, some people still have this idea that changing these old parts is detrimental to the value of an old amplifier, and I'm just here to tell you it's not. Don't listen to those people. They don't know what they're talking about. Okay, here we are. We've got everything we need out to start doing some measurements. We've got the dummy load back here. I've got it hooked up to the output, and it's set to 4 ohms, like this amp wants to see on the output. We have the new output tubes. Also have one of the tubes with a socket probe. This is a bias probe that I made. I've made a few of these. I made it for very, very cheap, and I made it with a cheap Harbor Freight multimeter, which is actually very accurate. I've measured it against my Fluke, and it's dead on. It's very accurate for these measurements, and it works very well. We're going to turn that on, and what this is doing is it's the bias probe. All it's doing is it's interrupting the plate connection between the tube and the actual socket. So it's getting in between the tube itself and the socket. And I'm taking off from the socket on the plate one lead, and I'm taking off from the lead that goes to the actual plate inside of the tube with another lead, and I'm basically taking those 2 leads and running it through the meter and measuring whatever current that we're drawing through that. So this will measure plate current. This will measure plate voltage. We'll set this on voltage, and I'm taking this voltage off of right here. So I've got this voltage right here. This is coming from this meter, and it's plugging just right into here. So basically it's going to the plate. It's going to the plate of the tube. Okay, so this will give us our plate voltage. This will give us our plate current. Let's go ahead and turn this on. We'll start dialing up the variac, which is going to give us voltage to the amp. And we'll start out slowly here. You can see we're already at 53 volts on the plate of the tube. And it's going up quickly and steadily because this has a solid state rectifier, and you don't have to wait for a tube to warm up to get instantaneous voltage. Alright, we're getting some current. We're getting some signal. We've got 64 volts on the input. The current here is climbing pretty rapidly, actually. Okay. I don't quite like that. That's just running away. That's running away. Did you see that? That current just kept going up and up and up. So I don't know if we've got some kind of short, possibly. Something's not right in Denmark. Let's dial it back up a little bit. We'll go to. Okay, see, we're getting current right here. We've only got 200 volts on the plate, and that's going to start dropping as this current should probably start going up. We might get something over here, we might not, I don't know. Let's go up to 64 volts. That's going to get us about halfway. Now we'll start getting something. Is this actually going to change with the... I think this thing's got massive problems. Look at this. Look at this. Watch this go up. Look at that figure right there just going up and up and up and up and up. We're at 90 watts, 100 watts of power, right? Look at that, 100 watts. And we're only at 63 volts in. This thing is way wrong. Way wrong. Look at that. Look at that current. All right, I'm turning the bias pot. And look, it's still going. But we got to kill this. Yeah, something's not right. I think we got massive problems here. This isn't going to be just a case probably of popping new tubes in and biasing it. So let's flip this thing over and see what's going on. We've already changed the power capacitors. So let's go down the power rail and see what voltages are looking like. Let's do this again. Let's fire this back up. We've got this flipped over, and I want to look at some voltages in various places. I'm going to dial this back up to about, let's go to about 55 volts for a second. And let's look at screens. 213, 213, 213, 212. What do we have on our negative supply? We got nothing. We got no negative supply. Aha. We've got no bias voltage. We got no negative bias voltage. So I'm thinking probably that bias diode is probably bad, or we have something else here in this circuit is bad. Let's look at it. Are we getting a good connection here? Is that tight? Sort of. Not really, but sort of. Let's test that diode right there. Okay. Anything? The diode looks good. Looks like a diode. Half a volt. Except possibly not. Okay, on a healthy diode, you should get about a half a volt in one direction. Okay, we're getting about a half a volt measuring in one direction. This is a healthy diode, okay? Now, if we go the other direction, we get over limit or open. That's the way a healthy diode is supposed to measure. This one, however, look, we got about a half a volt in one direction, and then we got the same the other direction. That's a bad diode. Let's measure this resistor here too. Should be 1 and 0 and 2 more zeros. That's correct. That's exactly dead on. So that resistor is good. Let's check this capacitor. This setting, don't be confused, because it does capacitors and diodes in this setting. It just depends on which of these buttons you hit. If you're in voltage mode on this, it's set for diode test. If I press it again here, that gets me back to see there nanofarads. Now it's ready to test for capacitor. Now the capacitor hasn't been changed, and we should change that. 75 volts, 80 microfarads. I'm getting nothing there. That's clearly not right. Something's not right. Yeah, okay. We got a bad capacitor and a bad diode in our bias. We need to go ahead and change both of these capacitors right here. Change that diode, and then let's come back and see if we start getting bias voltage. This is a 70s Fender Twin, and it is quite different from the 60s ones. One of the differences is, instead of a bias pot, which is what I kind of was thinking that was, but I'm wrong. I had forgotten that these models had a balance pot, not a bias pot. So you see this pot right here, so that balance pot right there We follow that down. It is coming off of the negative supply. So here's where our negative supply comes in. This point right here, this 3.3K resistor, that's that resistor right there. So this resistor is going to this point at this junction of the capacitor and the diode. So if we follow that, and indeed it comes right here to this junction of this diode and this capacitor. Right here you can see that there's no big dot. So it's not tied onto this rail right here. It's not supposed to be. This is a ground rail. If we follow this down, eventually it takes us to ground, to chassis. This is not supposed to be tied there, but if we look at this junction right here between this diode and this capacitor, that's this point right here, it is at ground. You see that? We basically have almost 0 ohms to ground. So there's a short from that point right there somehow to ground. If you follow the diode path back, it goes to the winding. So that would not be an easy way to get to ground unless the turn was shorted somehow to ground, which would be catastrophic for this amp. I'm going to assume that it's getting to ground some other way. If there was a short in this capacitor right here, that would explain it, because on the other side of this capacitor, it does go to ground. So this capacitor right here, it's looking like that might be shorted. Let's pull that capacitor out and see what it measures out of circuit. The other thing that it could be, now I have seen cases online from others where other people have talked about these boards in these amps. It can get so absorbed in moisture and get so crystallized, maybe carbonized, that it starts to become conductive and can conduct to ground. There's also a possibility that we just simply have maybe some solder ran down. Maybe it's as simple as one of these leads is touching the chassis underneath there or something like that. If this doesn't prove to be the issue, we can pull this all up right here. We'll take this screw out and pull this board up and see if we're getting a direct connection to ground right there. We'll lift that leg and then we'll remeasure and see if that disappears, that connection to ground. That's looking better. See there? That's looking better. If we touch this capacitor back to the spot, that's it shorted. So we had a shorted capacitor. Look at that. Instantly it gets shorted to ground. Shorted capacitor. That's probably not the root cause. What probably happened to cause that to short was the fact that somebody threw a quad of 6v6s in this amp. And you could see from every single one of these 6v6s they'd been red plating. Okay, and since we have taken that short to ground out of circuit, now our diode looks correct. You can see we're testing it one direction and it is open. If we test it the other direction, so I'm going to reverse my leads, and then you should get about 1/2 volt. So let's test it the other way again. Now, this is correct, it's testing correct, but when we apply this, suddenly, it probably, no, it's not going to do it now. It's making a liar out of me. Oh, that's because I didn't have this side connected, because I lifted that leg. If I connect both of these to the spots where they were connected, suddenly look. I'm gonna lift that again. You see, now it's testing correct, but if I push this back down, that connection, see? It makes it look like that diode is at fault. Really, that right there is at fault. I put this pencil here last night because I wanted to point this out. This standby switch has been replaced. You see that black screw? But look how close that is to that terminal on that switch. Look at that. I want to do something about that and make sure that that's not even anywhere near it. Let's see if I can bend it. I just want to kind of bend it away from it, if I can, like that. I feel much, much better about it. Okay, I have here a schematic for an AB763. So this is the old blackface version of the Fender Twin Reverb. And if we look at the bias, we've got a resistor right here, which is a 470 ohm resistor coming off of the tap for the bias that provides the bias voltage. It goes through this resistor, through the diode, and provides us with a negative voltage right here on this rail. It comes in to one of the legs of a 10K pot, but it's filtered also. So you got the negative side of the filter here, and also at that in conjunction with this reverse diode right here is giving us the filtered negative voltage coming into this pot. On the other leg, you've got, what, a 27K resistor right here to ground. So this is setting up a voltage divider, which allows us to adjust the voltage. Okay, so that is how the bias is set up in one of the older versions. Then it goes on to the center of these 220K resistors, which feeds each side of the output tube grids. All right, so that's really standard. That's the old way things were done by Fender. But then they came along in the 70s and did this. So here's where the supply originates, and you'll remember we had a resistor in the other one that was 470. This one is 1K, which is probably still fine, and we will most likely leave that value alone. Then it goes through a diode again and gives us a negative voltage, just like in our other schematic. It's laid out a little bit different, but it's the same exact principle. So that's all the same so far. And then it's filtered. It's a filtering capacitor right here with the negative end here and the positive end going to the ground rail. Then it skips over this, goes through a 3.3K resistor to here. So that's like a dropping resistor. You can see this is like a power rail, like this power rail. You know how everything gets rectified. It gives us this voltage right here, which is unfiltered. Then it comes here and gets filtered, and before it goes on to usually a dropping resistor, but in this case we have a choke, and then that goes down to another dropping resistor. You know, so that's how power rails are usually laid out. Well, this is the same way on the bias. So it gives us a negative voltage, gets filtered, dropping resistor, which drops the voltage from 63 volts down to what, 52 volts? So they're basically giving you the prescribed voltage with these chosen values here and here, and not giving you the option to really adjust it. The only adjustment that you have, again, is this balance pot, but we'll get to that in a second. So like I said, we had a filter here, a dropping resistor here, and then another filter. So this point right here is getting filtered also. So it's getting filtered twice, which probably isn't a terrible idea. I mean, to filter your bias voltage 2 times rather than 1, it's gonna cut down on noise. So Fender was actually really trying to cut down on noise there, and you could tell, you know, by adding that extra filtering capacitor, that's what they were doing. And also they were upping the value of that capacitor from 50 microfarad in the old one to 80 microfarad in the new one at 75 volts. So they actually beefed it. They actually beefed this up quite a bit, and it's a better circuit, with the exception, I think, of the balance pot. That's the only thing I don't agree with, is the inclusion of the balance pot setup rather than the other setup. So this pot right here, it has 2 wipers. So the voltage comes in, the negative voltage, and it can go one of 2 ways depending on where you set this pot. You turn this pot and it's going to balance the voltage on this side with the voltage on this side, but it might not be equal. You're going to balance it according to the lowest noise, essentially, and the best tone, and probably equal output on both sides. Because back in the day, you know, when these came out in the 70s, you had a lot of tube manufacturers that were becoming a bit more iffy with their product, and they weren't quite as reliably matched and things like that. So it made it easier for you to get just any old set of tubes and just pop random tubes in here, and then use this balance pot to balance the 2 sides, this pair of tubes and this pair of tubes, so that you kind of had a consistent push-pull from both sides, and it would be less noisy, and it would be probably, you know, have a little bit more power and stuff like that as well, which it might have been a good idea in 1974 when this amp came out. They might have had their reasons, but now I don't necessarily see a reason to do this. I think it's better to probably leave these values. So I'm going to leave this, I'm going to leave this, we will leave this filter value alone, I'll leave this alone, I'll leave this alone. We're going to change that into a bias pot instead. Okay guys, I'm going to try my best to show this in some detail exactly what I'm doing here. So we do need to change these capacitors, so I'll go ahead and do that. I'm going to replace those actually with 100 microfarad 160 volt capacitors. Upping the value is not a big deal. Lowering the value, you got to do some calculations a lot of times, so just be careful when you're doing this kind of thing. I'm just going to cut this leg and leave this. I'm going to leave this attached right here because that's going to ground. That's my ground connection. And again, positive in toward ground on this. Okay, there's one down. This one we're going to replace also, but we're not going to tie it to this point on the back of this pot. This is a second wiper on the back of the pot that will not be used in our new configuration, or our old configuration, I guess is we should say. So I'm just going to clip this one out, and I'm going to leave a little bit of lead to use as a tie point. Again, always note your positives on these bias rails are to ground, so the positive end is going to go to ground, but again, we're not going to tie it off of this. And also this resistor is going to be moved as well, so let's go ahead and desolder this resistor and also this white wire that's going back here. This white wire, if we were to follow it over here, it goes to, I'll show you where it goes in a second. Okay, it goes to right here. There's a 2.2 meg resistor that feeds the grid of the tremolo tube. That's where that's going, and it needs to reference that this rail also. You know, it's funny too, because you'll get a lot of people, they'll, oh, we're going to blackface your old Fender, or, you know, we're going to blackface your 70s Fender, which is fine. Like what we're doing right here, we're blackfacing essentially just the bias circuit. We're not completely blackfacing it. We're keeping the good ideas and we're getting rid of the bad ideas. So extra filtering, I think, is probably a good idea. Now, I mean, somebody out there might disagree. Maybe you have good reasons for that. But it seems to me that a little bit of extra filtering on the bias supply is going to clean up the bias supply and probably make the output a bit cleaner as well. Reduce hum and all that sort of thing. So I see no reason to, you know, get rid of the good ideas in pursuit of just blackfacing the amp. It doesn't make any sense to go that extra mile to blackface only to get rid of some stuff that might improve the amp. A lot of people will also remove the master volumes, but I mean, I got news for you. If you just leave the master volume on full blast, it's out of the circuit. Don't even use the push-pull feature. I mean, who cares if it's there? Why make a big stink about it? Just don't use it, you know? That's always bothered me. Just people, they'll poo-poo something without even really thinking about it. Okay, also in this version of the amplifier, we have some 68K resistors. We have one right here coming off of one leg of this pot, and we have another one. If we follow the other leg of the pot over here on this white wire, it comes up here to the board, and then there's a 68K resistor right here that's tucked in. We need to replace both of those with 220K resistors like we had in the original amplifier. So in this one, they replaced the 220s with 68s. We're going to go back to the 220s. Okay, so far I've replaced one of these resistors, and I'm replacing these with a metal type resistor rather than the original carbons, because these are in a basically a power supply for the bias, and I don't want those really ever failing. So we're going to give those a little bit of a better resistor. But also, one of the resistors was coming from this point, okay, the junction of this capacitor over to this leg of the 10K pot. This resistor was fully on the board and was coming from here. If you follow this white wire, it goes to there and then goes to this junction here, feeding this other pair of tubes. In the old version, both of these resistors were coming off of the same point that was coming off of the wiper. So we've got to move this to the wiper, that white wire right there, and we're going to change this configuration too so that both of these get fed. Sure that wire doesn't get melted on there. So now we've got this white wire coming to this point, and we have two 220K resistors, each of those feeding a pair of output tubes from these 2 points. On the other end, we want to change this white wire, move it to the wiper, the center lug. That you can see there's already a resistor here. The resistor needs to be deleted. All right, white wire to the wiper. One of these legs is going to feed pretty much all three of these, and it's going to be this one closest to everything. So we're going to shorten this wire. We only need about that much. And if you're doing something like this, you know, don't take the shortcut and just bunch that wire up. I mean, go ahead and shorten it and restrip it. You might as well, and just make it nicer and cleaner in here, rather than just, like I said, there's a short way to do it, quick way, and then there's a better, longer way. Just put in a little bit of extra time and make it nicer, you know. It doesn't take that much. Same story here. I'm gonna shorten this resistor, say about that much, and we'll have to shorten this as well. So we'll take a little bit off of that. And same story here. I only want to use as much as I need, so something like that. You know, and again, some purists are probably going to look at this and say, why aren't you just removing that and doing the full black face? You know, it seems to me that more filtering is better than less filtering. So I would rather err on the side of slightly more filtering. I don't see the reason not to. I mean, we've got a solid state rectifier here, so, and I don't want to forget to put that back now that I'm thinking about it. You know, I could have come in also and changed the value of this resistor right here. I could have changed the value of that resistor from a 1K down to a 470 ohm, like in the original version 2. If you want to do that, go for it. If you want to do it fully black faced, you know, change that to a 470. Get rid of this altogether. Get rid of this and just put a wire, solid wire from this point over to this leg, and then delete that, and then change this from an 80 down to a 50, and then you're black faced. But I like this better. This is the better circuit of the three possible circuits that we're talking about. You know, the combination of the best of both worlds. Now our other leg needs to go to ground, but through a 27K resistor. I'm going to see if I can get away with a 22K. Wait, that's not a 20, that's an 8. That's an 18. I don't have that. What do I have here? Hang on. I think I'm going to do 2 15s, which is going to give me a total of 30. 30 is about, that's pretty close. That's what I'm going to do. I'm going to tie two of these together and go 30. Okay, so now this bias circuit is black faced. Or to be more accurate, now it actually has a bias circuit. Okay, I think the thing to do now would be, let's go ahead and fire it back up and see if these changes is giving us a bias voltage. Okay, before we go firing this thing up, I'm gonna go ahead and clean this pot. And we'll hit it with some contact cleaner first, and then we'll hit it with some lube. We'll set this about in the middle. Now it's going to be a little bit off from what it originally would have been, because this is a 30K resistance instead of a 27K. But let's go ahead and fire this thing up and see where we get to. All right, let's see what we've got now. Dial this thing up and see if we start running away on the output like we were before. 45 volts in, 50 volts in. About 65 volts is where we start usually warming things up. We should start seeing some current here. Our wattage is way better. Okay, now we're starting to get a little bit of something, but it's not running away like it was, so that's a good sign so far. Let's give it a little bit more juice. We'll go up to maybe 350 volts on the plate, and then it's kind of chill there for a second. We're going slow and just making sure that everything is stable. We're starting to get something at the output, looks like. It's a bit noisy. I can tell it's a bit noisy. Maybe that will clean up as we dial it on up a bit. Hopefully it will. But it's definitely noisy. Of course, we're going in the vibrato channel. You can see all the crackling on that master volume pot. We got to clean the pots. Wonder. That's just, I'm just changing the ground switch there. This is me just, look at that. That's me just touching the chassis. Look what I'm doing. Look. Okay, but we're 94 volts in. We're at 51 watts on the power. 354 volts, and we're real low. We're real low, so I expect this should clean up hopefully as we dial this on up. We'll also adjust the bias here in a second too. Okay, there's 120 volts in. We have 85 watts of power, which I already know is low for this amp. Okay, just prodding around here, one of the issues I see is right here. Somebody's been messing with this because this socket right here, these grids, I believe that's the grid. Let's see. Okay, wait, that's a cat. What have they done here? Okay. Somebody has been messing around. These two were pushed together almost all the way, and they might have even been touching right here. That's the cathodes. That's both of the cathodes for this tube. And let's see, are those supposed to? Yes, those are supposed to be tied together. But what am I looking at here? Because is that the reverb too? Because look, coming off the grid on this tube, we're going to the reverb output. But those are not tied together. Let's go ahead and drop some solder on that, because that's not right. This is what happens when you get someone else's project amp. You inherit their project problems, and there's nothing less fun really than that. It's fine if somebody's fully capable and they do a good job and everything's wired correctly, and perhaps even leave you a schematic, which is nice, or a video, you know, to reference. Wink, wink. Which is even better. But when you inherit this kind of stuff, man, it can get real unfun. Let's see if I can get it up a little bit. There we go. And you have to wonder, you know, if I've just found this one just by looking at it, how many others exist that might be hidden, you know? Okay. Now those two are tied together, which is all well and good, but I don't know that that's really going to help me. It might, though. Let's fire it back up and see what we're looking at on the output now. And one thing that did kind of concern me a little bit was that the power consumption, the overall power consumption, was creeping up to about 145 watts overall, which in itself shouldn't be a huge deal, but it seemed like it was creeping up and up and up slowly. It just kept going upward. So I don't know, that's something definitely to keep an eye on. But let's see what we've got going on now. Maybe we got lucky and that's all it was. Let's look at our output actually. Okay, that's better. That's actually looking right. That's looking correct. Wow, okay, way better. Way better. Way better. Let's see how far up we can get it when it, before it distorts. Now we're starting to distort a little. And we've got maximum clean headroom right there. Alright, that's looking way, 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 way better. Let's check our vibrato. Let's short that vibrato switch. I can see that the light is working for the vibrato, but there is nothing happening. But I'm guessing that the light dependent resistor is faulty. This thing has a lot of clean headroom even where it is, bias wise. I think it probably would be just fine where it is, but we might try to eke a little bit more out of it. I need to change those resistors in that bias supply. these two, remember I put a 30 here, which I think is too high. We're going to back that on down. Maybe put a 22 or something like that in there. Okay, I lowered this total value down to about, let's see, 18, down to about 23. So let's try that. Okay, we need to dial that up to something close to 30. Stop right there for a second. 30.8.0308 times 432, 13.3. Okay, now we've got that up to 39. So let's try that. 0.039 times 426 plate volts. That's 16.6 watts of plate dissipation per tube, and that is a little over 50%. That's 50 something odd percent. So that's getting us in the ballpark of kind of where we need to be. Problem is that adjustment's all the way up. If this doesn't, I'm going to look at it on the scope. If this doesn't work out, I might have to replace those two resistors one more time. We've got full compression here on the top of the wave, a little bit on the bottom. It's a little bit asymmetrical, but we're getting full compression right there, full squared off wave with very little crossover distortion. Actually, there's really no crossover distortion there. If I want to back that down until you actually see crossover distortion, you can see what I'm talking about. See, I back this down. You see this little hump in the middle? That's crossover distortion. We can get rid of that. We're going to dial that out right about there. That's looking really beautiful to me. That's a gorgeous looking wave. Alright, I think we've pretty much got that. Let's check the other channel. Okay, this channel's looking pretty good too. I'm gonna call this one fixed. We've got new tubes with bias. We reworked all of the bias circuitry, and to me everything right now at least looks pretty good. The only other thing we need to do is fix the tremolo, or the vibrato, which doesn't work. It's actually a tremolo, which doesn't work. This is an optical style tremolo, which means that there is inside of that black thing right there, inside of this, there's a light, and also at the bottom, you can see it's kind of rounded out at the bottom. There's a resistor down there that varies depending on how much light falls upon it. Sometimes those go bad. Sometimes the lights also go bad. But the light, at least we know, is working. The resistor is kind of another story. We can put our probe on here and see if that's changing. I'm going to measure across that resistor, the resistor legs here. So I'm going to tie one of these probes on one leg, one on the other leg, and then that's going to lead over here to my fluke. Let's turn that on and see what kind of voltage fluctuations, if any, we're getting there. Yep, we're not getting anything. What about on the other side? Maybe I've got that backwards. I don't think I do. I think that is the resistor side. Okay, you can see right there. That's the bulb side, so that's working. Yeah, I think it's our resistor inside the roach. I think that's the problem. It must be. Now the light only really has one intensity, so the intensity control doesn't work with the light. The light turns on and off with the switch. So like if I remove this, that should stop. And it does. This is basically just shorting the tremolo to turn it on. Okay, so, and you can also see it with the light too, inside of that roach right there. So right now it's on. If I remove the ground, it goes off. So I think it's the resistor that's inside the roach is not working properly. It's open. Yep, that'll do it. Since we know the lamp is good, we might end up reusing it. We'll see. The resistor's toast, but maybe this will give you an opportunity to see what one looks like. They use these from the, Blackface era on. but that's what your light dependent resistor looks like. Let's see what I've got on hand. I've got a bunch of those of different values. Okay, so luckily I labeled this bag Ampeg Gemini and Fender. We'll take this one. Here's a part number, but I don't know if that has any meaning. 5468. So this is what the new style looks like right here. And it's much smaller than the old one. See the difference in size, but it still should work. I'm gonna get our leads going one way here, like so, and we'll reuse the same lamp because it was working. Okay, we need a piece of shrink tubing. Probably should have tested it first, shouldn't I? Since I don't know for certain if it's going to work. Might have been a good idea. I am about 90% confident though. Okay, new roach installed. Let's see what she does now. All right, so here's our waveform. Let's see what happens now when we turn the here jumping now. So it is working. Speed knob's working too. Speeding it up. That's the fastest speed, and then on down to the slowest. So okay, tremolo's fixed. Alright guys, we are back with this twin reverb, and it is confession time. So when I went to buy tubes for this amplifier, the customer said he wanted to go back to 6L6 GCs, and I said, well, okay, so he really didn't have any preference that he gave me for tubes, so I just went and shopped for tubes. I came across this company called Nesstone. They sell these, you can get them on eBay. You can also get them directly from their website, Nesstone. So they import, you know, tubes just like everybody else who rebadges tubes. They import tubes, they match them on their equipment, and then resell them. Well, I had read some decent reviews on these things, and they have two different types of 6L6 GCs. One is a Russian variant, and the other I think is a JJ or possibly Chinese variant. I can't remember now, but I'll put it up on the screen, the two different variants, so you can know what you're getting into here. So yesterday when I finished biasing this amplifier, play tested it off camera just for a little bit to see if everything was okay, also to test the reverb because I had not tested the reverb yet, and it was fine. I played it for about good, you know, 5 to 10 minutes with the amplifier facing away from me, looking at the back of it to check on the tubes. And eventually one of the tubes did start to red plate, and I was like, oh crap. So I shut it down real quick, and it wasn't a big deal. It just started, you know, get glowing the cherry red, that red, you know, it's red plating. I was like, well, why is it doing that? Because I just now biased these things. I checked it. It's well, you know, it's like 50% or whatever it was, under 50%, I think, of plate dissipation total for 6L6GC. Well, I got to looking at these tubes, and I want to show you something. The tubes that I was sold as 6L6GCs are not 6L6GCs. These are a Soviet era, new old stock tube that is, they're often sold on eBay. Here's another one of them, and I've got a couple of sets already on hand, and I've been using these in other amplifiers because 6L6GC is a quad of matched ones. It's just gotten really expensive. So I've been ordering these of late and using these. They're not 6L6GCs. That's the only problem. But when I compare this, the construction, everything about this pretty much, right down to the spacers involved, I mean, these are an exact match. Everything down to the getter, the flashing around the getter, all of it. The spacers, the construction of the plates, it's an identical tube, and it's a 6N3C in Cyrillic. That's what it looks like, 6N3C, but it's like a 6P3 whatever. I don't know. I can never remember it. So these tubes are not 6L6GC equivalents. Exactly. These are closer actually to a 5881 equivalent. They dissipate about 20 watts or so per tube, and that's the maximum. So you want to bias these probably to around 10 to 11 watts really to be within a safe margin, and I was biasing them way too high. So right now, if we check the bias, I'm going to go ahead and rebias these and make sure that we're good, because I'm just testing them again, and I've let this thing warm up now. It's up to full temperature. We've got 24 milliamps and 441 volts, and if we do that calculation right there, that's 10.7 watts per tube. Now, like I said, the maximum plate dissipation on these is about 20 watts. So 20 times point, I'm gonna shoot for about 55%, and that's about 11 watts. So right here, these are doing pretty good. And actually, I'm gonna back down even just slightly, just ever so slightly, because I don't want it to kind of ever creep up above that. So these are now biased correctly. Before, I had biased them too hot because I was biasing them as regular 6L6GCs. There are a ton of these out on the market right now. They're being unloaded through Ukraine. I'm not sure what has happened in Ukraine. I mean, I know they've got a war and everything. But I know back during the Soviet era, during the fall of the wall, and you know, there are a lot of movies out there you can watch. You know, Lord of War is one of them that springs to mind. You know, where after the fall of the Soviet Union, they had all these weapons and military grade everything, basically flooded the black market and all that stuff. Well, I would say what happened is they had a huge, probably cache of this tube, and they were just everywhere. They were just flooded everywhere, and nobody really knew what to do with them except for call them 6L6GCs and put them on the market. Well, they're not 6L6GCs, but they are a close enough alternative that you can bias them to 5881, and they do operate very well. I've used them on a couple of amps in the past with great results. Excellent tubes, but they're not a 6L6GC. So I wanted to make you aware of that. If you order this tube from Nesstone, make sure you don't over bias these. You want to bias these as if they are a 20 watt maximum 5881 and not a 6L6GC as they have labeled them on the boxes. Well, if you order these, be very careful. You're not getting a 6L6GC. In fact, you're better off just buying quads of these that are sold on eBay, honestly, and they're going to be sold a little cheaper if you buy a quad of these on eBay. And like I've done before, and I've got, like I said, a couple of quads already on hand. I did not know that I was buying this same tube again, but accidentally that's what I ended up getting. I'm going to leave these in here. These are great tubes, but now that they're biased correctly, they're going to last and they're going to be perfect for this amp. But you know, if you order some of these for yourself, just make sure you know what you're getting into and bias them accordingly. In addition to the numbers, if we want to look at the actual scope on this, there's the point of compression right there. We back it down to where we've got basically a waveform, and we have really no crossover distortion here at all. Maybe the slightest hint of a little bit, but it's nothing. You really don't even see any crossover distortion. Really, if you're just seeing distortion right there, it's because of the black lines on the screen. It's not because of actual crossover distortion. But that's a very beautiful looking wave right there. Looking great all the way up to the point of compression, and beyond compression, you do get a little bit more of the crossover distortion here in the middle. You see that little bit of hump of waviness right in there. There's a little bit, but it's not pronounced. It's excellent. That's a great looking wave right there. Like I said, these are excellent tubes. This thing is operating perfectly now, and full clean bill of health. This thing is ready to go, and it's ready to go probably for another 40 years. One other thing I noticed is that this amp was shipped to me with only one 12AT7 in it. So the rest of these were 12AX7s in all these other positions. So I moved the AT down to the phase inverter where it's supposed to be, and there's supposed to be another AT7 right here on the reverb. The reverb did work, but I noticed that it was a bit overloaded. So I'm going to try to track down a 12AT7 that I can replace this with, and trade that tube out for the reverb driver. Ready, and... guys, that's going to do it for this video on this 1974 twin reverb that's been cut down into a head. I hope you've enjoyed this one. If you have, hit subscribe down below. Also join me over on Locals. There's a link down in the description. It's kind of like Patreon, but I get to say more stuff over there. I get to say stuff I probably wouldn't even get to say on Patreon. But yeah, let me know if you like this type of video with the one-man band demos at the end. And if you do, which one of the demos did you like best out of this lot of songs? Let me know in the comments below, and for now, we'll see y'all later.